So yesterday we learned all about sine and cosine on the unit circle. And today we are going to focus more on tangent, but kind of on all three because they go together. As a reminder, tangent is what over what? Opposite over adjacent. So if y'all can just look up, this is not in your notes right now. If I ask you to find the tangent of this triangle, I guess I can't move it. What do we know? What do we got to do? What's tangent again? Opposite over adjacent. And do you agree that opposite this 45-degree angle is right here? What value did we learn that was yesterday? That's the y value. So tangent is y over what's the adjacent? X. That's the x value. Do y'all agree with that? And didn't we also learn yesterday that when the radius is 1, our y value can be represented as what? Sine of theta. And our x value can be represented as cosine of theta. Do y'all agree with that? All right, now yesterday we did this one, but you could do it again in your head. What would the y value be right here? Square root of 2 over 2. And what's the x value? Don't you agree they're the same because it's a 45, 45, 90 triangle? So I'm going to divide. What is the square root of 2 over 2 divided by the square root of 2 over 2? Why? Anything divided by itself is... Y'all, the tangent of 45 degrees is always 1. Okay. Now, what about 30 degrees? Yesterday, we said if this was 1, what was this? If this was 1 and that was 30 degrees, what was this? 1/2. And then what's this down here? Square root of 3 over 2. So if I want to do tangent again, I'm going to do opposite over hypotenuse, which is... No. Man, why am I messing up so bad? I messed up yesterday with y'all too, right? Opposite over adjacent is 1/2 over square root of 3 over 2. What is that going to... How do I do that? Did y'all learn or do y'all remember keep, change, flip? No? Okay, we are going to keep the numerator. Keep it 1/2. Change this divided by sign to a multiplication and flip the denominator. Did y'all learn keep, change, flip? Some of us, yes, some of us no. Does that make sense what I did? Because dividing is the same thing as multiplying the reciprocal. So that's what I just did. What happens here? The 2's cancel, and what am I left with? 1 over square root of 3. Is that acceptable? No. So what do I got to do? Rationalize. So what am I going to get for my tangent here? Square root of 3 over 3. So the tangent of 30 degrees is square root of 3 over 3. Last but not least, 60 degrees. For 60 degrees, what did we say our x was right here? 1/2. And our y? And again, we have to do the opposite over adjacent. What is my opposite? What is my adjacent? And just like we said, it's a lot of divided signs. I'm going to keep the top the same. Change it to multiplication and flip the bottom. What happens? My 2's cancel. And what's my answer? Those are the tangent values for 30, 45, and 60. Now, let's go back to the first slide. Could I have just always done y divided by x? That's essentially what we did, right?
Good afternoon. Pardon this interruption. It is time for group 2 which is our second floor classes in portables 104.
Where have we seen
B.
y divided by
You
x
will need to
before?
take your belongings to this pep rally as you will be exiting the building once it is over to go home. So again, students, you will
Wait
need
till
to
she's
take your
done.
belongings to this pep rally as you will be exiting the building to go home at the completion of the pep rally. Again, all second floor classes in portables 104 and 217 A and B. Please make your way to the performance gym. Thank you.
Somebody said slope, another person said rise over run. That's exactly where we've seen it from. And so that's what I like to say tangent is like a good representation of, is slope. Do you agree my point here was square root of 2 over 2 comma square root of 2 over 2? And you do y divided by x, and that's how you get tangent. I like to say it's the slope of this line right here. Same thing right here. You're just dividing your y divided by x. That's the slope of that line right there. All right, so that's going to come into play when, what if I have a point right here? What if I do 150 degrees? What's the tangent of 150 degrees? Well, do you think that, or do you agree that these lines are kind of a reflection of each other? But what's the difference? This line is negative. So this slope would instead be negative square root of 3 over 3. Okay. What about right here? What about 210? What's the tangent of 210 going to be? Isn't it the same line as this one right here? It's the same slope, right? If it's the same line. So those are going to have the same values. So that's how we are going to figure out the tangent for each. So I would like you to get out yesterday's notes. As a quick reminder, tonight, remember, just you need to watch that linear and angular speed video in Schoology. All right, our notes, if you can please go to yesterday's notes. I believe on the table of contents, we titled it Sine and Cosine, right? That is not this notebook. I would actually like you to add and tangent to it because I'm just going to add a little piece about tangent on here. So sine and cosine and tangent. And then we're going to also do page 12 in a little bit too. XYR problems. So go back to your page yesterday. Do y'all have a little bit of room somewhere on your page yesterday? So if you don't, and you're like me and you write big, I'm literally boxing out like right here on the bottom. Hold on. I'm literally boxing out a part right there. That's all I need. So your tangent of theta, tangent, do you agree, is opposite over adjacent? What's my opposite always going to be? Y. What's my adjacent always going to be on the unit circle? X. So tangent is like the sine of theta over the cosine of theta. Those are three different ways to represent tangent. And what did I like to say that I think of it or I relate it back to? Slope. It is your rise divided by your run from the center. Can you get out your salmon sheet, please? Oh, wait. Yeah, get out your salmon sheet. So I'm going to do my tangents on the inside and I'm going to box them so that I know. Well, what about 0 degrees? What would the tangent of 0 degrees be? What was the slope of a line that looks like this? 0. And I'm going to box it. So that's the tangent of both 0 and 2 pi. Does anybody remember what we said the tangent of 30 degrees was? No, that was 45. 45 degrees is 1. That was the first one we did. And why is it 1? Because what's your y divided by your x? What about tangent of 30 degrees? Square root of 3 over 3. And the way that I have memorized this is actually connected to the radians. What is 3 plus 3? 6. That's how I remember that one, square root of 3 over 3. And then what was pi over 3 or 60 degrees? Just square root of 3. And look, this one's the 3, the 3. What about the tangent of 90 degrees or pi over 2? What is the slope of a line that goes straight up and down? Huh? Undefined. The tangent at 90 degrees is undefined. Because remember, what's the slope of a vertical line? Vux. Did y'all learn Vux? Hoi Vux? Vux is undefined. And now we just need to think of slope and directions. It's all reflected. All the ones over 3 are going to be what? Square root of 3. But is this going to be positive or negative? Negative. Because if I were to connect this to the center, that line is going down. What is the tangent of 3 pi over 4? Negative 1. And the tangent of 5 pi over 6? And again, all the ones that are divided by 6 will have square root of 3 over 3, and it's going to be negative. What about the tangent of 180 or the tangent of pi? 0, it's a flat line that's horizontal, hoi, 0 slope. What about my third quadrant? Say it louder. It's the same as the first quadrant. Why? Because I can go across, it's the same line. Also, when you divide, what's a negative divided by a negative? A positive. Y'all can finish this. I do want y'all to be careful. Some of you, when you write your square roots, you do a square root like this, which is fine. But please make sure that you are making it obvious if it's a negative versus if it's part of that. Because if I start questioning, does that make sense what I'm saying? So if you're somebody who does your square roots like with a little tail, make sure you make the negative obvious or don't connect them or things like that, because I won't understand what you're doing. All right. If you want to, down here, you can do like a little key. The tangent of theta is boxed, just to let yourself know. And then it is cosine of theta and sine of theta. I believe we have written everything that we are going to write. Did everybody that wanted one get a page protector yesterday? If you did not, I have some more. Y'all can come up and get them. Keep your salmon sheet to the side. Yeah, put it back in the page protector, but keep it to the side. We're going to come back to it at the end of class. All right, now we are going to do XYR problems, which was page 12 in our notebook. So we do XYR problems. Let me just make sure I'm showing y'all everything that they wanted. Oh, we did the quadrantals, right? Yeah, we did that. Opposite, cool. We are going to do XYR problems when we are not using any of the points on our unit circle. So remember, what's the radius of this circle right here? No, that's the number of degrees. What's the radius? 1. This unit circle has a radius of 1. So what happens if we don't have a radius of 1? Or if I'm using a random point? Like, is 1, 1 one of the points, on my unit circle? Is 1, 1 one of the points on my unit circle? No. So what happens if you have that point? You can still find sine, cosine, and tangent. You are just going to do an XYR problem. So what I would like you to do, please, is do an X and Y axis, and we're going to draw a circle. I find that it's easier to draw circles if like you do a C and then like a backward C. It ends up looking pretty good. And if I were to choose a point right here, do you agree it would be represented by X and Y? I would say this right here is theta from there to there. And do you agree I can make a right triangle with Y and X? How would I find the cosine of this theta? What is cosine? Adjacent over hypotenuse. So what is my adjacent here? Oh, just kidding. I forgot to label this. What's this right here? The radius. That is my R. So it would be adjacent is what to theta? X. What's my hypotenuse? R. What about the sine of theta? Y'all agreed sine is opposite over hypotenuse? So what would sine be? Y over R. Now, yesterday, cosine was just X and sine was just Y. How come today it's a fraction? We don't know the radius, or the radius might not be 1. So that's why we're setting this up like this. Last but not least, today we just learned, or we've always known, tangent is what? Opposite over adjacent. But what is tangent letters wise? Y over X. If you look at your yellow page, these are what these examples look like, where I tell you A point on the terminal side of angle theta is given. Find the values of cosine. That's what this means. Hey, I'm giving you points that are not on the unit circle. Can you find the trig functions? That's when you would use this. So tomorrow, when y'all are in here, y'all are supposed to be doing homework up to number 40. Y'all can do these. You're just using this page that we're doing right now. Okay? So, if you look at that, do you agree on all of these? I gave you points. I'm giving you the X and the Y. How do I find R? What does R stand for? Radius. How do I find the radius? How do I find that radius if you know X and Y? Louder? Nope. Pythagorean theorem. But instead of a squared plus b squared equals c squared, we're going to say r squared equals what? X squared plus y squared. By the way, r is always positive. Will your X and Y always be positive? No, they're on the graph. They can be any X, any Y. However, your R will always be positive. So we're going to do 2 examples. And the first example says, I'm going to change this. The first example says the terminal side of an angle in standard position. We learned this already, but what does standard position mean? What does standard position mean? We learned the other day. If the angle starts at the origin and one side lies on the x-axis. So if it's in standard position and it passes through 3, 4. So I can put a point, I'm just making up where it is, at 3, 4. And I know this is going to be my angle right here. That is what that is saying. How do I find the cosine of theta, sine of theta, and tangent of theta? Let's make a right triangle. What does my x equal? 3. What does my y equal? 4. And we need to know r. What does r equal? We could do 3 squared plus 4 squared and square root it. Or if we have 3 and we have 4, that's a Pythagorean triple. We know it's 5. Either way, you're going to get the same answer. Now you have your x, y, r. You're just plugging in your information. Cosine is what over what? Look up here. X over r. So what is my x? What's my r? That's your answer. That's it. You leave it as a ratio. You're not inversing. You're not going to have a calculator to do any of that. Just leave it as a fraction like that. What is sine? Y over R. What's my Y? What's my R? Yeah. Last but not least, what's tangent? Y over X. What's my Y? What's my X? Do I have any questions? Okay, is it always going to be that easy? No, the next one we're going to do, it's not going to be that hard, but it's always, the next one's a little bit more difficult. It says the terminal side of an angle in standard position passes through -1, -3. So again, example 2, this is our last example today. Does drawing it like that help or no? Or your circle's just crazy? They're just crazy. Where's -1, -2? Third quadrant. Now I'm just guesstimating. You don't have to have a perfect number right there. I'm sorry, -1, -3. It said -1, -3, not -2. And I'm gonna make a right triangle with this. Again, how am I gonna find R? Is this a Pythagorean triple? No. So you're gonna have to do R squared equals -1 squared plus -3 squared. What questions can I answer? Say that louder. Wait, what? What? San, did I do something wrong? What? San is what? Be careful. It's -3 over -1, which is 3. We like that one. Why are we laughing? I have a fan in my face. I can't really hear y'all very well. What about cosine? Cosine is what? X over R. What's X? -1 over square root of 10. Can I leave it like that? No, you have to rationalize. Every year I have kids leave it like that on the test. Don't be one of those people. Don't leave me any square roots in the bottom. You do sine. Go. What questions can I look up when you're done, please, just to check yourself? What questions can I answer? We okay? We exhausted. Does it feel like Friday because of the pep rally? Y'all got one more day. Why did I say y'all? Because I will not be here tomorrow. A couple of reminders. Tomorrow you are doing numbers 1 through 40. Am I grading the odds? No. If you're doing the evens, do them on a separate sheet of paper. With the exception, y'all look in the back. There's the key. 17 through 23, or I don't know if it's through 24. 17 through 24. It wants you to do all 6 trig functions. You've only learned 3. So for 17 through 24, y'all leave some space for 3 more, but we haven't learned how to do that. Maybe you can figure it out, but don't worry about that. All right. But you can now do up to 40. Remember, I told you numbers 37 through 40 are what we did today. Okay. Your quiz on Monday. And again, I'm not going to make your quiz on Monday the beginning of class, but your quiz on Monday is going to go over sine and cosine. What's the do y'all have your salmon sheet out? Look at your salmon sheet, please. What's the cosine of 330? What's cosine mean? X. What is the x at 330 degrees? Square root of 3 over 2 is my answer. This is your quiz Monday. What's the sine of pi? Sine means what? Sine is, what's the y at pi? 0. What's the sine of pi over 3? Sine is y. What's the y of pi over 3? Square root of 3 over 2. That is complicated, right? Okay. So I want you to be prepared. I'm actually going to post this mini quiz in Schoology so y'all can practice. But look, y'all, I have added so much now to your unit circle. You have until Monday. So you have tonight. I know half of y'all are going to, well, maybe not y'all, but a lot of people are going to be at the game. They're going to be busy. So you have 4 days. There is a unit circle C practice and there are flashcards. Please make sure you are studying. You need to have this memorized. Do you need to have, and look, this is like a little game. Up here it says 4 pi over 3. Where's 4 pi over 3 go? Somewhere over there. Where's 2 pi over 3 go? Right here. Where's 270 go? And then you do in the degrees. 90. Where's 0, -1 go? Where's 1/2 square root of 3 over 2 go? So, right. I need you to study this salmon sheet by the time I get back because you have quiz C. Also, there's Quizlet, there's flashcards. So you can flashcard yourself and study. You need to have, but guys, if you have the first quadrant memorized, if you can have this first quadrant memorized, it's just a reflection of all of them. And honestly, I'm going to suggest you draw these first quadrant on the quiz and then answer the questions. Well, I mean, just the first quadrant. Does that make sense? 5 minutes, 20 questions. Maybe you get 7. I got to look it up. I don't know. What did it just say? Oh, 10 questions, 5 minutes. So do y'all want me to post this right here in Schoology? Okay, I'll do that for y'all. All right, y'all have a wonderful weekend. Tomorrow's homework, be respectful. Can y'all do me a favor? My first period has a test tomorrow. Can y'all separate the desks?